So far, we've discussed mole-to-mole, mass-to-mass, and volume-to-volume conversion problems. But by using stoichiometry, we could solve for any final unit. It doesn't always have to be the same final unit as the type of unit that we started with. So let's remind ourselves of these steps to calculate any stoichiometric problem. So step number 1 is to correctly balance the equation. Step number 2 is always our first bracket, where we convert the given amount into moles. Step number 3 and 4 is always our second bracket, where we set up our mole ratios and then use them to calculate the moles of the desired chemical that the question is asking us for. And step number 5 is to convert those moles back into the final unit. And using all of the conversion factors that we've learned so far, we can change step 5 to convert to any type of unit that we want. So there's a couple different conversion paths you can take. And you can write this down in your notes and try to memorize it if you want, but I don't really think it's necessary. If you know your conversion factors and you can work the brackets, you should be able to solve any problem I give you without having to memorize this. But it might be helpful to some of you, so I'll show you what I'm talking about by these paths here. So if we start with mass, and we want to convert to moles, in order to do that, we need to divide by the molar mass. If I wanted to go the other direction from moles to mass, I would multiply by the molar mass. If I was in moles and wanted to turn it into volume, I would multiply by the molar volume, 22.4 liters. If I was in volume and wanted to get back into moles, I would divide by the molar volume. If I was in moles and wanted to solve for particles, like say molecules or atoms, I would multiply by Avogadro's number. If I was going in the opposite direction, I would just need to divide by Avogadro's number. So you see we could convert from one side to the other by following the path. If I started in mass and wanted to solve for volume, I would first have to divide by the molar mass in step 1, and then in my last step, step 5, I would have to multiply by the molar volume. You just change the type of conversion factor that we use in the last step. It's really not that complicated. If we were in volume and wanted to get to molecules, I would first have to divide by 22.4 and then multiply by Avogadro's number to get to molecules. This is just going to be for the first and the last bracket. So let me show you an example problem here. If 2 moles of water are produced in the following reaction, how many grams of hydrogen need to react? So we're going to start with what they give us, 2 moles of water. And we want to convert from moles of water into moles of hydrogen. So they're asking us for hydrogen, so we want to convert to moles of the desired chemical. So we just look at the molar ratio. There's 2 moles of water, according to our balanced chemical equation here, for every 2 moles of hydrogen. So moles of water and moles of water cross off, and I'm left with moles of hydrogen. But I don't want moles of hydrogen, I want grams of hydrogen. So I know I need to set up another bracket. So I want moles of hydrogen to cross off, so I'll put 1 mole of hydrogen on the bottom, and I need to put the molar mass of hydrogen on the top. So hydrogen weighs 1, but in H2 I have 2 hydrogens, so that would be 2. So moles of hydrogen and moles of hydrogen cross off, and I'm left with grams of hydrogen, which is what the question is asking us for, and that's how I know I'm done. So you see this problem only required 2 brackets, and that's going to happen sometimes with a mixed problem. So 2 times 2 divided by 2 is really just multiplying by 1, so you could skip this if you'd like. But 2 times 2 divided by 2 times 2 is going to be 4 grams of hydrogen. So in this next problem, let's convert from moles to liters. So what is the volume in liters of oxygen produced if 3.5 moles of hydrogen react? So we'll start with the number they give us, 3.5 moles of hydrogen. And our first step is we want to convert into moles of oxygen. So according to the balanced chemical equation, there are 2 moles of hydrogen for every 1 mole of oxygen. So I'm going to have 1 over 2. My moles of hydrogen and moles of hydrogen will cancel. And then I need to convert from moles of oxygen into liters of oxygen. So in 1 mole of oxygen, at STP, I have 22.4 liters of oxygen. So moles of oxygen will cancel off with moles of oxygen. I'm left with liters of oxygen, which is what they're asking us for. So again, another 2-step problem. And it's time to punch it in my calculator. 3.5 divided by 2 times 22.4 is 39.2 liters. Okay, one more problem. Molecules to mass. If a billion atoms of sodium react in the following equation, how many grams of NaCl will be produced? Do you remember how to write a billion? Well, this is on your reference table, your prefix table here. A billion is 10 to the 9. A billionth would be 10 to the negative 9. So a billion is 1 times 10 to the 9 atoms of sodium. So our first step is to convert that into moles of sodium. So in 1 mole of sodium, we have Avogadro's number of atoms of sodium. So atoms of sodium and atoms of sodium will cross off. And next I need to convert to moles of sodium chloride here. So I have moles of sodium, and I need to use my mole-mole ratio to turn moles of sodium, and I have 2 of them, into moles of sodium chloride. So for every 2 moles of sodium, I have 2 moles of sodium chloride. So this won't change our numbers, but you see it changes our units. Moles of sodium and moles of sodium cancel. I am now into moles of sodium chloride. So I need to do one more step to get to grams of sodium chloride. So in 1 mole of sodium chloride, I need to find the molar mass. So I go to my periodic table and I look up sodium. Sodium weighs 23 grams. And then I need to look up chlorine. Chlorine weighs 35. When you add those two masses together, you get 58 grams. And you plug that into your last bracket there. Now moles of sodium chloride will cancel off with moles of sodium chloride. I'm left with grams of sodium chloride, which is what the question is asking us for. So I know it's time to punch this into my calculator. I would punch in 1 times 10 to the 9 divided by 6.02 times 10 to the 23rd times 2 divided by 2 times 58. And if you did that correctly, you will get 9.6 times 10 to the negative 14 grams of sodium chloride. Okay, one more problem here. Let's try this one on your own. Go ahead and pause the video, and when you think you've solved it, unpause it, and I will solve it for you. Okay, 100 grams of CH4. First step is to convert that into moles. To do that, we need to divide by the molar mass. CH4 contains a carbon, which weighs 12, and 4 hydrogens, which each weigh 4. 12 plus 4 is 16 grams of CH4. Next, we want to set up our mole-mole ratios. We want to convert out of moles of CH4 and into moles of CO2. It's a 1-to-1 ratio. For every 1 mole of CO2, I have 1 mole of CH4. So that will cancel off moles of CH4 and moles of CH4. And then our last bracket is to convert to the desired unit. They're asking for liters of CO2. So I want moles to cancel off, and I want to turn this into liters of CO2. And 1 mole of CO2 at STP, I have 22.4 liters of CO2. Now I'm left with liters of CO2, so that means it's time to punch it into my calculator. These units, of course, will cross off. 100 divided by 16 times 22.4 will give me 140 liters of CO2. Okay, so to solve any stoichiometric problem, follow the 5-step approach that we've learned. You need to start with a balanced equation, convert the given amount to moles, set up your mole-mole ratios, and then use them to convert to the moles of the desired chemical, and then your last step is to convert to the desired unit. The first bracket in any stoichiometric conversion is to convert to moles. Your second bracket is that mole-mole ratio step. The third one is to convert to the unit of the desired chemical. Remember, write units as you go and cross off above and below to make sure you're setting it up right. If you skip this step, I promise you, you will make mistakes. If you do this, if you write this down like I'm demonstrating in all these videos and in class, I promise you'll get in a really good habit and you will get more problems correct because you'll be able to catch yourself when you've made a mistake and you've flipped conversion factors incorrectly. You'll be able to catch it as you cross off and fix it before you go ahead and start punching wrong numbers into your calculator. If you do these steps, you should master these problems really easily, and this should be no problem for you.